In February 2002, as part of the New South Wales state and federal government's upgrade of the Pacific Highway between Newcastle and Brisbane, Thiess were awarded a contract to design, construct and maintain a new 10-kilometre section of 4-lane freeway bypassing the town of Karuah. The bypass route traverses through a number of highly sensitive areas, including state forest, nature reserve, a salt marsh wetland, an island, a mangrove wetland, a river, several creeks and rural pastures. The project, valued at approximately $100 million, included 2 major bridge crossings. The first, over protected wetland, was approximately 200 metres long, while the second, crossing the Karuah River, was approximately 600 metres long. These crossings resulted in the construction of Australia's longest incrementally launched bridges. From an engineering perspective, it was quite a challenge. But there were many environmental challenges as well, as the project involved a variety of environmental issues. Archaeological studies conducted prior to construction identified a number of significant sites that needed to be protected. So Thiess developed a close relationship with the Karuah local Aboriginal Land Council. Members of the council were invited to the site to search for artefacts, and for the purposes of education and promoting Aboriginal heritage, a display of artefacts was established in the main site office. 4 scarred trees were identified in close proximity to the new freeway, so signs and barricading were erected to protect these important trees. Protecting the local Aboriginal heritage was considered in both Thiess's bridge design and construction practices. The new bridges were specifically designed and built to span over a significant Aboriginal midden on the bank of the Karuah River, leaving it safe underneath for future generations. Not only were there Aboriginal heritage sites that required protection, but a European one as well. Investigations of survey plans from the 1890s revealed the existence of a corduroy causeway. This log causeway must have provided early settlers with a crossing to Horse Island through the wetland. Part of the bypass weaved through open woodland and paperbark forest, so to compensate for the trees that would be lost to clearing, the Roads and Traffic Authority acquired other land within the same area. This land was then returned to the National Parks and Wildlife Service as compensatory habitat. Prior to clearing, it was vital to reduce the potential for animals to be harmed. So Thiess engaged ecologists to identify which trees possibly contained fauna. These trees remained untouched until all others were felled, and by the time these habitat trees were ready to be removed days later, any fauna had long since moved away due to the noise of the machinery. This proved to be a very successful process. Nest boxes were erected in nearby trees to replace any hollows that were lost during the clearing process. Trees cleared were recycled in many ways. Most of them went to a local factory to make weatherboard products, while much of the rest was mulched for landscaping. Other uses included sediment barriers, underpass furniture, fence posts and firewood. Recycling was not limited to trees, however. The earthworks were designed so that no excess material was produced, or no importing of earth was necessary, and most of the quarry products needed were crushed and processed on site. During early site investigations, 2 threatened flora species were found. Tetratheca juncea, or black-eyed Susan, was one, and Engophora inopina, or black apple, was another. To help protect and preserve the species, Thiess clearly marked these shrubs and trees with high-visibility warning tape, and whenever non-essential works were to be constructed in an area, it was first assessed for the presence of the species. Soil conservation was one of the most critical construction-related issues for Thiess. To ensure its effective management, Thiess engaged professional soil conservationists to advise on all aspects of erosion and sedimentation. Some of the techniques adopted included retaining vegetation in flow lines until the last possible moment, timber sediment barriers built from felled vegetation, progressive hydro-seeding, concrete-lined drains to separate clean from dirty water, and the construction of over 30 sediment basins to capture dirty water runoff. The water in these basins was then cleaned with gypsum using an innovative pump system designed and built specifically for the project. Only clean water was ever released into the environment. After opening the freeway to traffic, these basins assume a secondary role, acting as fuel and chemical traps should there be a pollution spill. Baffles, or retention weirs, were built in front of the spillways to prevent any floating chemicals from escaping. As a long-term protection measure for the wetland and river, all runoff from the bridge decks was captured and taken inside and piped back to the shore for discharging into water quality basins. To accommodate the abundance of fauna in the area, Thiess designed and built a number of 3-metre high by 3-metre wide fauna tunnels under the roadway to allow the free and safe migration of koalas, possums, wallabies and other fauna. Special koala-proof fencing linked the underpasses together, preventing the animals from wandering onto the road and effectively directing the animals safely under the freeway. The tunnels have been designed to be as fauna-friendly as possible, containing an earth and mulch flooring and a climbing rail to give the animals some protection from predators. An extremely simple yet effective method of increasing the number of crossing points for fauna was to build a recess into the floor of all the drainage culverts. This means that even if the culverts had water flowing through them, animals could still cross through on the dry sections either side of this recess. At bridge locations where large amounts of rock flood protection was placed, concrete footpaths were built over the rock to encourage fauna to cross at these locations. Glider crossings are being built on the Karuah bypass for the first time on such a large scale. The initial consideration was to leave natural vegetation in the median strip to allow the gliders to cross to the centre of the freeway. From there they would be able to complete their journey to the other side. Ultimately, this was replaced with a better solution due to traffic safety concerns during storms and the unsuitability of the median trees. The alternative solution used ropeways draped across the freeway. These would provide passage not only for the gliders but for possums and other arboreal fauna as well. The trialling and development of these proposals, in consultation with various government agencies, was an excellent example of the cooperation possible from all sides of the project to achieve the best possible outcome for the environment. The areas at greatest environmental risk during construction of the Karuah bypass were the sensitive wetlands over which the two major bridges were to pass. Thiess's innovative construction method, called incremental launching, provided the wetland and river with the least possible impact. This is because of the fact that the superstructure, or top section of the bridge, is not built over the wetland and the river, but is actually built on the land and pushed out. This means that the amount of impacted land is reduced because less work is required down at ground level. Ground access is still required to build the piers that support the bridge. However, the amount of disturbance in the wetland and river is significantly reduced. The challenge was to construct the temporary roadway in such a way as to minimize the impacts on the wetland. So Thiess constructed it out of good, clean rock overlaid on a geotextile fabric. On top of this rock, a road base layer was placed to stop any pollutants from infiltrating through to the wetland. The surface was sloped to one side, where an innovative sand filter strip was installed. The sand strip captured any pollutants, and any contaminated sand could then simply be replaced. Cross drainage pipes were installed under the roadway to maintain the existing tidal flows in the wetland, so that aquatic fauna may move around freely during spring tides. Another environmental advantage of the incremental technique was that the bridge could span further between piers, compared to the traditional precast bridge method. Greater spans therefore meant less piers, and less piers meant less disturbance to the wetland and river, and less time spent in these sensitive areas. The bridge is also more attractive the fewer piers it has. Maintaining high standards of water quality was critical in the area, because of the significant wetlands and because the Karuah River supports a prominent oyster-growing industry. Consultation with the local oyster farmers was undertaken in order to understand their requirements, such as not allowing tannins to leach into the estuary from decaying timber. Floating curtains surrounded marine works that had the potential to cause turbidity. These curtains would also contain any chemicals in the unlikely event of a spill. All operations with the potential to pollute waters were risk assessed and control strategies identified. Emergency response materials were always close on hand to contain any spillage. Regular testing of the water quality in the river and local creeks ensured that any changes could be quickly picked up and addressed. Thiess believes that community involvement was essential to the success of the project. So a community involvement group was established to effectively disseminate information about the project and to discuss any issues of concern raised by the residents and business people. Site tours generated from over 50 community presentations attracted more than 80 busloads of local tourists. During the 2.5 years of construction, over 5,000 people were either spoken to or visited the site, a truly remarkable effort by Thiess and the RTA. Thiess's excellent community efforts were recognised with the winning of the New South Wales Tidy Towns Business Partnership Award, a joint submission with the residents of Karuah. The judges had this to say about Thiess. The Karuah Bypass project is an excellent example of what can be achieved by consultation and the positive outcomes that can be achieved by both communities and business working closely. Thiess have made an enormous commitment to the town of Karuah and have backed this commitment with practical examples. The Bypass project is an innovative engineering construction that sees a highway and a river bridge crossing constructed in the most environmentally sensitive manner possible. The overwhelming community response to the project is positive, due largely to the sensitive consultation and ethical way in which the project has been designed and managed. Sustained positive outcomes will benefit the town of Karuah from this partnership. Information dispersed through the media, the project website and permanent display centre at the main site office kept residents well informed of the project's progress. But perhaps the most intriguing visual technique for keeping the community informed of progress was the time-lapse cameras installed on the project. 2 cameras snapped images every 15 minutes throughout construction, and using the latest in high-definition technology, the many thousands of images were run sequentially to produce a fascinating time-lapse record of the bridge works. Thiess's design and construction of the Karuah Bypass demonstrates that major infrastructure works can be produced successfully in sensitive environmental locations. The 10-kilometre Karuah Bypass is yet another road on our journey towards a sustainable environment.